Good afternoon, ladies and gentlemen, and welcome to this Royal Aeronautical Society Air Law Group webinar. I think the first in the Air Law Group's history meeting by virtual format, and I hope this will only be a temporary state of affairs. I'm speaking to you from the IATA offices in Geneva, from a deserted Geneva airport, which just shows the extent of the crisis that we're facing. But whilst we are in the depths of this crisis, there are a number of important developments going on within the industry and a number of developments which I think will impact on how our industry operates out into the future and indeed recovers from the crisis, and none more so than the topic of artificial intelligence and aviation. And I think it's an increasingly important topic, one which really could bring about significant changes in how the business operates. So we're really delighted to have this webinar today with a really distinguished panel of experts who are going to talk us through a number of the important issues that it raises for our sector. Thank you to all of them, and thank you to our colleagues at the Society for helping us bring this webinar together. Thank you to all of you. We've had huge interest in this event and a really significant level of participation, which is extremely encouraging, extremely rewarding. And as I said, I hope that will continue when we are able to all meet again face to face. Just a couple of housekeeping issues to cover off. You are all, I'm sure, getting used to meetings and events in these virtual formats. You are all in listen-only mode, so if you need to communicate with the organisers at any time, please use the chat function in the webinar. There will be Q&A after each of the two sections of our webinar today, each of the presentations. So please submit your questions. Again, use the chat function in the control panel, and you can do that right the way through the presentations. If you have a specific question for a speaker, please feel free to include their name at the start of your question. We can make sure it's directed accordingly. We'll do our best to address any questions that you have. Just to point out, today's webinar is being recorded, and the link to the recording will be emailed to all of our attendees afterwards. So that's all from me. I'm going to now hand over to our moderator for today's session, Gilly Belsham from INS. She's one of the world's leading aviation practitioners. She has both a disputes and an advisory practice and a really broad scale, broad range of aviation clients all across the sector. And her expertise in this particular topic will be very interesting for us as she guides us through the discussions with our distinguished set of speakers. So Gilly, I'm going to hand over to you. Again, welcome everybody. Thank you for joining and really look forward to the discussions.
Michael, thank you very much indeed. Sorry that it's from a deserted Geneva airport, which I think is a great sadness to us all. Good afternoon, everyone, and good morning to those who are joining us from the West. I share Michael's pleasure in introducing a real panel of experts here to talk us about this absolutely fascinating subject of artificial intelligence. And as Michael says, this may well be something which will help the industry and is already helping the industry deal with the current crisis. We're going to kick off with the first session, which is AI, Technology, Law and Ethics, which will be given to us by Matt Hervey and by Lee Glazier. And I'm going to tell you a little bit about Matt and Lee. Matt is head of AI at Gowling WLG. He is co-editor of The Law of Artificial Intelligence, which is coming out, being published by Sweet and Maxwell in the autumn of this year. I'm sure that's a book we'll all want to buy. Matt is a member of various AI working groups, including for the ICC, the IP Federation, and other AI and IP bodies. And he also has considerable expertise in IP disputes within the aviation sector and indeed elsewhere. Lee Glazier, who is head of service integrity at Rolls-Royce, brings a very interesting perspective to the table as he helps lead the continuing development of the AI vision at Rolls-Royce to deliver tangible business value and business benefits from AI. Lee has created the Rolls-Royce process for governing AI ethics and data ethics, and has collaborated as appropriate with people from teams such as HR, ethics, data scientists, engineering and the trade unions, demonstrating the very broad range of stakeholders that need to be consulted and brought on board with this far-ranging topic. So I'm going to hand over to Matt first, followed by Lee. Matt's going to consider key technical aspects of AI for lawyers, new legal issues raised by AI, including liability, privacy, IP and access to data, and ethical concerns. Thank you, Matt.
Thank you very much, Gilly. I hope you can now see my slides. As Gilly explained, I'm Head of Artificial Intelligence at the law firm Gowling WLG. And this session, the first of two, is going to look first at AI as it presents challenges for everyone, so issues that will arise in aviation in common with all sectors. And the second half of the webinar today looks at the use of AI for specific aviation functions, so for manufacture, maintenance, fuel use, and so on. So in this section, I will start with AI in general, its definition, why it matters now, and the technical aspects most likely to create legal issues. I will outline the most significant legal issues and give a flavour of the plans to regulate AI in general. And then I'll briefly set out the need for ethics and then hand over to Lee Glazier for a discussion of ethics in practice at Rolls-Royce. Now, there is no universally accepted definition of AI. And I think the definition I've chosen for this slide is a good one, and it was adopted last month by WIPO, the World Intellectual Property Organization. And it says, a discipline of computer science that is aimed at developing machines and systems that can carry out tasks considered to require human intelligence with limited or no human intervention. And I want to just draw out 4 aspects of this definition, which suggests that AI, in fact, by definition, raises social and legal issues. The first is that it relates to tasks considered to require human intelligence. But what is considered to require human intelligence is a constantly moving target. No one thinks of a pocket calculator as artificial intelligence. Second, the focus is machines tackling tasks normally performed by humans. This has inevitable economic and social impacts. We will see machines performing jobs more cheaply, faster, reliably, and tirelessly compared to their human counterparts. And this will change human employment, the end of some jobs, and we hope the creation of new jobs. Third, although AIs target human tasks, AI may not perform the tasks in the same way as humans. Indeed, AI may be very different. It may be hard to predict, and it may be opaque in its decision-making. And finally, these machines may operate with limited or no human intervention. AI may act autonomously, and some may autonomously change their behavior over time. But actually, AI has been studied since the 1940s, and even the neural networks, which are so important now, were first attempted in the 1950s in physical form, and I've shown a picture of the perceptron from the 1950s. But suddenly, AI has economic, social, and legal concerns for us because of a leap in performance over the last 10 years. In 2012, Google built a neural network of 16,000 computers, trained it with 10 million randomly selected YouTube video thumbnails over 3 days. And from these random images, it learned to recognize cats 75% of the time. This was a practical proof of the power of machine learning. And machine learning is merely a subset of artificial intelligence. But it has been enabled by academic research into the effectiveness of training with ultra-large data sets, increasing computer processing power and memory, and critically, the availability of vast amounts of data generated by the digital age. And the critical point is this: machine learning enables a computer to program itself, to crack skills that people have not to date been able to program, to automate automation. And almost all discussion of AI is really discussion about machine learning. Now, there are many approaches to machine learning, but ultimately all learn to recognize patterns, such as matching a handwritten shape to a number that it represents. And these patterns could be anything: undervalued shares, films to recommend, people to date. And among this pattern finding, the most socially transformative have been enabling machines to see things and to understand language. And these 2 skills in particular have unlocked a vast range of once human tasks across all industries. With vision, a machine can see and label the world around it fast and accurately enough to enable self-driving cars. And with the same techniques, a machine can distinguish benign and malignant cancers. But for big tech, and perhaps some car companies, there's an even greater goal. With language understanding, a machine can be your interface to the world. Everything you search for, everything you watch, everything you listen and do and buy, taking a slice of the entire economy. And this has the attention of governments around the world. A flurry of countries have published strategies for AI from 2017 and beyond. And the UK government has made AI one of 4 focuses of its current industrial strategy. AI is increasingly seen as significant to both economic growth and national security. Indeed, the UK government has now proposed to add AI to the list of business activities subject to heightened merger control and interventions by the Secretary of State in relation to national security. Now, AI can outperform humans in specific tasks at image classification, dispensing prescriptions, or at playing Go. But that disguises many current limitations. And I'm going to group these broadly into 3 categories. First, there is no general artificial intelligence. AIs can only perform a single narrow task for which they have been trained. AIs have no common sense, no understanding of the world. I've pictured here a self-driving truck. It's a 15-ton truck that failed a DARPA challenge in self-driving in the desert because it did not know that it could drive over tumbleweed. And the performance of AIs is brittle. They can fail, and their failure can be hard to predict. They may be vulnerable to hacking and even subtle adversarial attacks where their inputs are subtly changed. When they do fail, they can make baffling errors, errors that no human would make. Second, most, though not all, machine learning relies on the availability of large quantities of suitable data. If the data is not representative, the AI will not perform well in the real world. You will have cameras that miss faces and cars that do not recognize cyclists. If the data is representative but reflects unwanted human biases, AI may perpetuate those biases through job recruitment, parole decisions, and medical spending. And if the data was once representative, but the world has changed, the AI's performance may drift. Third, the operation of AI may be opaque. Most do not follow deterministic logic, and the models may be complex and incomprehensible, and their operations may continue to evolve. In response to these issues, we have seen only a smattering of new laws. For example, there have been new laws covering the use of automated decision-making, liability and insurance for self-driving cars, and exceptions to copyright to enable data mining. But there is ongoing urgent work to regulate AI. The UK Centre for Data Ethics and Innovation is working on UK regulations, and the EU President has vowed to regulate AI within her first 100 days, albeit that has been knocked off course by COVID. But it is part of a general focus on AI and data by the EU. These efforts are being spurred by the importance of AI and also a sense that we are in an international race. If the EU can win the race to regulate AI, then it becomes a world centre for AI and for data trade, while exporting European values, such as a focus on privacy. For lawyers, the immediate challenge is to identify how the current law will apply to the new scenarios created by AI and how the law is likely to change. I've listed here the chapters of a book I'm editing for Sweet and Maxwell on the law of artificial intelligence. You can see the areas of law that we think are most likely to be affected. I'm going to talk briefly about 4 of these areas. First, competition law. This appears on the very first page of the summary of AI in the House of Lords report. There is a clear interest in the UK and the EU in data portability and generating a competitive market, and there is clear concern about big data incumbents, particularly US Big 4 tech companies. Second, balancing the need for data with the need for privacy and informed consent. Again, this was a key focus of the House of Lords, It is also a key issue in the European Commission's European Strategy for Data, and it is part of WIPO's latest paper on IP policy. Third is IP. There is a massive interest in IP, reflected in a growth of patent applications, which have risen 400% in the last 10 years. But there is a general and growing realization that IP law is not really fit for purpose in many ways. It is difficult to patent AI technology because much of it is old or known, and a lot of it falls within computer programs as such, which is an exemption. And an invention generated by AI is probably not patentable. And data per se is not an IP right. So patent offices around the world are looking at reforms to the law. And in the interim, all companies must consider trade secrets and contractual measures to define who controls data and who owns the models created by AI. And the last legal issue I'm going to talk about is liability. The EU Parliament has considered these issues and has proposed, for example, splitting responsibility between the supplier of an AI and the user educating the AI, and that this would be on a sliding scale. The more training given by the user, the greater their relative liability. They have proposed strict liability backed up with insurance, a robots tax to create a centralized compensation fund, and even the possibility of liability and indeed rights for the AI itself. This is a huge topic and is also addressed in the second session today. But I just want to point out one key trend, which we've already seen in the GDPR, and that is the requirement to achieve certain design principles by design, in particular to achieve what is required for trustworthy AI. So for example, privacy by design, avoiding bias by design, logging information to achieve accountability by design. Such things need to be baked in from the start and will need evidence throughout the development of a product from the very beginning. I'm going to hand over to Lee in a moment to discuss ethics at Rolls-Royce. And from my perspective as a lawyer, ethics is essential for AI for two reasons. First, law and regulation lags behind all technological change. To give an example from my own world, IP, the UK government took 13 years to change copyright law to permit recording of broadcasts to video. Second, AI in particular raises greater risks than most technology. It has a faster pace of change, it relies more heavily on personal data, it makes decisions that can cause physical and economic harm, in the case of self-driving cars, for example, and it has the potential to change society for better or worse, reduced in my slide to an image of a pizza delivery robot. Now, this delay in lawmaking and the particular risks presented by AI can require companies to look to ethics, to predict where the law will end up so that they develop products and services in a manner that will remain legal, to protect the public from harm, to protect the company against reputational harm, and to maintain public trust in AI generally. And on that note, I will hand over to Lee to explain how all of that is achieved in practice.
Thanks, Matt. Thank you for that, Matt. So, my slides be seen. Yeah. So as Matt was saying, I'm going to take you just through a journey in Rolls-Royce, how we've created an AI ethics framework to ensure that we bring artificial intelligence into Rolls-Royce in an ethical way. So first of all, just looking at the philosophical challenge that one has with AI. So if I just look at what we've got there, which is the flow from pure data to a decision. So I have data, imagine an Excel spreadsheet full of a load of cells, with data in it. I convert that into information, so I may create some graphs, and then I can start to see things. From the graphs, I will then know something. So I've got now knowledge, and with enough knowledge, I start to understand. I'll see trends, I'll see various things happening within the graphical information. And then by applying wisdom, various policies, various morals, etc., I'll then make a decision. So as a human, those are the steps I go through, from data through to a decision. So where on there would we see AI? AI goes straight from data to effectively understanding, seeing the trends. It misses out information, it misses out knowledge, and goes straight from data to the equivalent of understanding, being able to spot the insights. And that gives us a problem because we can't do an audit on the AI to find out, as I would with a human. So what information did you glean from that? What did you know? What did you understand? Can't do that with AI. And that's what's called the black box problem. So if I look at the sorts of trustworthiness issues that can give me when I don't really understand what's happening inside the black box, if I just look at a few types of AI deployment. So here we've got facial recognition, image recognition, predictive maintenance, CV sifting, various uses of AI. Then I will see the trustworthiness issue comes from, as Matt said, the AI can mutate, it can reprogram itself. As more data comes in, it can become biased, the output can become untrustworthy. And the impacts of this potentially are around facial recognition, can be ethnicity or gender bias, wrong person, on image recognition, features can be missed or classified incorrectly. Predictive maintenance, we can maintain too early or too late. If I'm doing CV sifting, bias can creep in, I can overlook candidates, I can miss the best candidates. And that's an interesting one for me because that is very unethical, but it's also bad for business as well. So if you've got really bad artificial intelligence, you've actually got real stupidity, and you can miss best candidates, which is an ethical concern, but also a business concern. And the two often do combine. Bad ethics is often bad business. So the way we approach this in Rolls-Royce, rather than try and get inside the black box and understand what's happening, because 10 minutes later it may have changed if there's been a reprogramming or a mutation within the AI, we actually work outside the black box. So we have what we call 5 Rolls-Royce parallel checks, and these are basically a sense check, so check that the data is within the expected range. A continuous test system, so continually put through synthesized inputs or gold standard inputs where you know what the results would be and look for those. An independent check, so that can be different data, different algorithm, or even a human doing checks, looking at independence. Comprehensiveness check, ensuring that you've done the right number of checks, and also data integrity. Has there been any corruption? Those are the 5 Rolls-Royce philosophies that we look at on all our applications of AI. Around ethical challenges and compliance, these are the things that we're continually challenged by. So in critical and hazardous applications, there will be existing regulations that still apply. There will be trustworthiness issues that we've got to be able to cope with. The deployment may impact resources, so trade unions may need to be engaged. AI is perceived as being potentially unethical. CV sifting and facial recognition are 2 very, very newsworthy examples of those sorts of challenges that we have. And where there's reinforcement learning or other sorts of machine learning, the AI can mutate after initial testing. So the testing can become invalid. And there are perceptions driven around unnecessary oversight or even unreasonable constraints that are starting to be talked about by various regulators. So if we move into manufacturing, I will see that there are various areas where ethical emotions can start to get raised. When I look at AI, robotics, if I'm looking at completely automated factories, or if I'm looking at decisions, either being supported or even made by some of the AI systems. These are the areas where we see challenges in manufacturing. So if I then move on to really look at the AI ethics, according to the World Economic Forum, there will be 75 million jobs lost due to AI, but there will be 133 million created. So nearly twice as many jobs created as there will be lost. So that's an interesting point. Obviously, the jobs will be different. On facial recognition, the EO in January stated that they were considering banning facial recognition for up to 5 years. I know that there are draft papers around within the EU looking at licensing or labelling of AI. So regulators and governments are really starting to look at this quite seriously. So in Rolls-Royce, what we've done is we've taken the references, the principal references, so the Good Corporation, EU ethics guidelines, the European Parliament Committee, some internal documents within Rolls-Royce and these are our AI principles, and we've used those as the guidance to create an AI ethics framework to help us govern the deployment of AI in an ethical way. And our AI ethics framework is split into 3. So we've got the 3 areas of social impact, accuracy and trust, and governance. Within those 3 areas, then we've got various contexts of benefits, human impact, communications, accuracy and trust, looking at the bias, looking at trustworthiness, and under governance, ethical use of the data, regulated use of data, and then looking at accountability and responsibility. So that's how we've then constructed our framework, and right at the centre, looking at bias and trustworthiness. So that's then put into a framework which has been completely proceduralized, which takes those 3 areas and the contexts, and it picks up the ethics and the guidelines and from the principles. And in there, we look at the various areas. So looking at potential job impacts, so working with the unions, maybe looking at upskilling, including looking at the external supply chain where there could be an impact on the supply chain's resources, look at loss of skills. If you replace skills with AI, then those skills may be lost forever. And that can be obviously a business issue as well. Looking at the trustworthiness, looking at data protection, and ultimately looking at accountability, especially where AI is maybe in a system of systems, where AI could be applied from different suppliers. And then looking at that in detail, this is what the areas look at. So if I look at specifically transparency and traceability, picking up there on the ethic from the European Parliament, and then looking at various realization principles. And there are 4 there, looking around the provenance of the algorithms, training data, hierarchy of decisions, and looking at whether the insights actually do improve things. The most important thing on our framework then is that evidence has to be presented as to how the ethic has been realized. So it takes the what from the guidelines, looks at the how, which are the realization principles, and then presents evidence to show that that ethic has been realized before deployment will be approved into whatever the area of the business is that we're going to put the AI. Maybe just looking at the accountability, this is a bit of a cartoon, but it does show the issue that you can have. Because we're on a webinar, I cannot tell whether anybody's laughing at that. That's the end of my talk, and now handing over to Gilly for questions and answers.
Sorry, Gilly, we can't hear you yet. Can't hear you yet. I'll kick off the first question because Lee, you were talking about potential job losses and job creation, but I believe you've had quite a role in liaising with unions as well. How did that go?
It was quite interesting, a bit daunting to talk to the unions, but I think there were two things that really helped with the unions. One was getting there early and actually giving them an opportunity to influence the framework that was being developed. So they first of all appreciated being able to make some changes to it, which they came along with and made some positive changes. But also it's quite interesting because the artificial intelligence applications within Rolls-Royce have been created by their own members. So the members of the unions have actually created the artificial intelligence in the first place. So they're really proud of the capability, and they acknowledge that Rolls-Royce needs to remain competitive and remain world leaders in the applications of whatever technologies are available to keep people in post and competitive. So there are various dynamics in there around their own membership that have created the AI, and then that they were brought in very early on to help influence the way that the framework was put together. So it was quite, those meetings, those presentations went very well, and they were quite enjoyable actually in the end.
Matt, can you hear me?
We can, that's brilliant.
Great, excellent. Thank you. Matt, fascinating overview of the challenges of this technology that can teach itself and automate automation. Absolutely fascinating. Just to sort of throw another challenge into the works of this, I was wondering what your views were of the impact of Brexit on the regulation of AI. Obviously, we have left 31st October is the deadline. Boris says he's not changing it. So we have 4 months to go. Well, what's your take on that in the context of AI?
Well, I think the EU is one of the front runners in regulating AI, and what we've seen with maybe US clients working with Europe with the GDPR, when you have a market which even after us will be approaching 400 million consumers, there'll be enough companies that are selling services and products into the EU that as a practical measure, they're going to have to comply with EU regulation. So I think that will continue here. We are, as it happens, I think irrespective of Brexit, looking at our own our own UK regulatory framework, and that will continue. But I do think there is likely to be little details where we diverge, and there's already one. So because of Brexit, we haven't put into our own law the same scope of exceptions to copyright for data mining. And data mining is absolutely essential to many commercial uses of AI, but we are not afforded in the UK the same breadth of exception as in the EU. And the EU is not in fact affording the same exceptions we're seeing in other countries, notably Japan and Israel and elsewhere. And so we are currently at a competitive disadvantage on that footing. Now we may change that, but that is one of the areas where we simply don't know where our law will end up.
Thank you, Matt. That's very interesting. More challenges, I think, there. I have another question which is quite topical, and that is, this is from one of our attendees. Can we use AI as a diagnostic tool to identify individuals who are ill? It's obviously rather too topical. And how would ethics come into play whilst developing AI tools for health-related applications with regard to potential patient confidentiality and all issues of that nature?
Well, I'll go first and then Lee can jump in. So AI obviously has potential to find any patterns in any system, given the right training. And long since we've had Google's flu project, where they used the instances of search terms to try to predict flu outbreaks. And there has been various attempts to harness AI for COVID in particular. But I would say life science is one of the absolutely critical areas for the use of AI, and that goes all the way from drug discovery itself through more efficient clinical trials and then personalized medicine and the like. But it is also one of the most sensitive areas when it comes to the clash between improving technology and maintaining privacy, and that is illustrated by the failure of the STREAMS project. This was a collaboration between DeepMind and the NHS to help people with kidney disease. And in the end, the ICO closed it down because even though it was going to produce major benefits in terms of healthcare, they unfortunately didn't have a proper consent, and I don't think they're necessarily taking the right care over personal data, and so it had to be stopped. And in the healthcare system in particular, all data practically is going to be personal. It is practically quite hard to anonymize data for an AI system, and AI systems are remarkably good at integrating multiple data sets which allow them to re-personalize once anonymized data. And also in healthcare, there are things such as the Calder Bank principle, which is really trying to avoid any invasions into privacy in the NHS. And that frankly has a bit of a freezing effect on the adoption of AI in healthcare in this country.
Yeah, one can see the real tension between, as you say, privacy and the advantages we get out of it. Lee, did you want to comment on that as well? If not, I've got one more question.
It's some very, very high level things. I think Matt was absolutely right. Where you've got lots of data and there are patterns, then AI is really operating very well in that field and generally can outperform human. So the answer is yes. I do believe that those applications can be very useful. Generally, I find that the ethics are more around the data rather than the AI, and GDPR is a great example of framework for ethical control of data. And whether anonymization or things that are coming in now, which are double tokenization, which is pseudo-anonymization, that really brings in some real good privacy, where really only the source of the data knows where the person is in that loop. As soon as it comes through to the people doing the AI, they've got no chance of actually discovering who the person was using double anonymization. So those things are around, which I think will give people confidence to allow the use of their data in those sorts of fields.
Yeah, I would add that that sort of technology has been used in healthcare at the moment to allow erstwhile competitor companies to pool data in a way where they don't actually reveal personal data and use the combined data sets to improve AI for the common good. The only word of warning I would add, and this is not a technical comment on that particular technology, but there is always an arms race, and what is seen to be cyber secure at one point isn't cyber secure 10 years later, and in the same way, anonymization may not be stable.
Yeah.
Okay, thank you. I've got one question, Lee, arising out of your talk. I mean, we've looked in one sense at one end of the telescope, your conversation, your collaboration with the unions to bring on board their stakeholder interest. I noticed in one of your slides, the transparency and traceability slide, you talked about the what, the how, and then the evidence to actually, if you like, ground that philosophical principle. And I was wondering how the business has responded to your putting in those kind of formal business processes, given the fact that it always imports cost, delay, time, all these things which put businesses under pressure. So how was that received by the business?
It's really been quite fascinating. If I look at more of the old school generally are quite well unionized. So the term of ethics in an AI field is something that they quite responded to quite well, purely because it was around unions. They could see it potentially impacting resources. So to have the unions involved, and you know that the unions were involved and the unions had blessed the framework, was actually a good thing. For the younger people within the organisation, the term ethics rang a bell. So they responded very well just because ethics was being mentioned. So the younger side of the organisation actually embraced it for a different reason. But yes, it's been very, very well brought in. And I think the whole thing actually is an enabler then. It's, I know what I've got to do. I mean, if you look at manufacturing engineering, this is not far off a checklist. They love a checklist. If I go through the checklist, tick all the boxes, put some evidence in there, I can now accelerate as fast as I want. So it becomes an enabler. it defines the tram lines within which deployment of AI can be done in an ethical way, and it brings quite a lot of good motivations around it.
Yeah, that's very interesting. Matt, did you have any comment on that?
Well, it's lovely to hear that any procedure is an enabler. It's not necessarily the reputation of lawyers when it comes to advising companies. But I will just say that I have to say it's genuinely in the last few weeks I've received a chapter on ethics for my book, and I've spoken extensively to Lee to really, the penny has dropped of just how important ethics is in this field, and also Lee is really, one of the few people I've been able to talk to who's actually gone through the step of proceduralizing it, and just to see the structure of the forms and the like is really interesting for me.
Yeah, I agree with that. I found that bit of Lee's talk particularly interesting, and I was very interested in your comment, Matt, about how ethics has to step in whilst we wait for law and regulation to catch up. Hopefully not 13 years, which is rather good in relation to videoing. I think we ought to move on to our second session, but I wanted to thank very much Matt and Lee for 2 talks that I certainly found very fascinating. I'm sure everybody else did as well. Thank you very much indeed.
Thank you.
Okay, well, session 2, having looked at, if you like, AI, not specific to the aviation sector, apart from through Lee's particular experience, we're going to now drop down a level and look at AI in aviation with, again, a very high quality panel. We have Simon Fippard and Lucy England, both of Bird and Bird, who I'll return to in a second, and Lee Glazier comes back as well. Simon and Lucy are going to talk to us about where and how AI is being used and what are the risks and the benefits of it. How does commercial risk in the aviation liability regime, with which we're all familiar, change when AI solutions are involved? And then Lee's going to come back and give us a case study of AI at Rolls. So Simon and Lucy, I'm sure will be well known to many of you. Simon is an aviation lawyer and has been one for more than 25 years. He's now of counsel at Bird and Bird. His speciality is commercial and compliance law, as well as litigation, and he advises leading businesses in all parts of the aviation sector, including airlines, OEMs, MROs, ATC, regulators, and others. He has a particular interest in innovative tech and AI, hence his participation on this panel. Simon also has seen AI perhaps earlier than some of the rest of us have, when he was at Rolls-Royce for 7 years, specialising in the engines aftermarket and advising on complex long-term engine contracts with airlines, suppliers and so on, which frequently involved the use of database methods to performance management and predictive maintenance. Simon, thank you for joining the panel. We also have Lucy England, a partner at Bird and Bird in their aviation and defence department. Lucy advises a full range of clients in the defence and aerospace sectors across a full range of issues that they bring to her. She also is especially interested in tech and data, and particularly in its capacity to drive growth and develop the sector, perhaps never more needed than now. She also brings an interesting perspective to the table, this time from BAE Systems, where she worked before joining private practice. So I'm going to hand over to Simon and Lucy.
Okay, and can you hear me okay, Julie?
I can.
Good. Okay, well, thank you very much for the introduction, and to Matt and Lee for their previous session. I hope you can all see the slides satisfactorily, because at the moment I've lost the slides. But perhaps while we're resolving that, I can just introduce our session. Perhaps I should also add my thanks to the Society and to the Air Law Group for the opportunity to talk about these subjects briefly this afternoon. Our aim over the next 15 minutes or so is for Lucy and I to give you some of our views on how AI in the aviation and travel sector raises a number of issues of commercial law, technology law, aviation law, bearing in mind that in some ways the industry is a very conservative one, but also employs enormous amounts of highly innovative technology, and always looks to more innovative ways of marketing its services and so on. So Lucy's going to start by looking at some of the applications and considering the benefits and risks that arise in the sector. I'm going to have a look at some of the questions arising in relation to safety and safety regulation, and also how the liability environment may or may not change with increased use of AI. And we're then going to look at the implications for the supply chain and how we think smart lawyers might need to think a little bit more differently in this world. Lee, as Gilly said, Lee is going to close this session with an analysis of how AI is being used for real within Rolls-Royce. And I'm certainly hoping that he's going to have some answers to some of the questions that we've raised. I'm particularly pleased at the moment to have the video. At our last rehearsal, my video failed completely. So if I disappear, that's because it's done that again. But we'll close, obviously, with the Q&A session, which Gilly is going to moderate. So please do submit your questions as we go through, and we'll do our best to answer them. But with that, Lucy.
Thanks, Simon. So I am going to start by just taking a quick look at how AI is used in aviation and aerospace. Some of this we've already heard from Lee and Matt. I think we've broken it down into 5 categories, and other people would categorize it differently. But our first is on the equipment design and manufacture side. It's being used largely for supply chain management, knowing when parts are needed and bringing them in for a just-in-time ordering basis. But it's also being used by the likes of Boeing and other OEMs who are using AI tools to make recommendations to the engineers in the design. So the AI isn't doing the design, it is just helping the human do it. The second category is analysis of both in-service performance and reliability. We've heard talk of preventative maintenance already and predictive maintenance, and it's the sheer volume of data now coming off aircraft, which can now be better analysed, and it's being used to develop tools and solutions to minimise AOGs. OEMs and MROs are more able to accurately or better price products and services by having some more insight and analysis. Our third category was smart flights or smarter flights, and this is how AI is being used actually in operation in the aircraft. And you'll have heard examples of AI being used in the cockpit to help pilots navigate perhaps during bad weather, or route planning, or helping to analyse fuel burn down on the ground to improve fuel efficiency either during the flight or analysis post-flight. And I think it's probably just worth saying here that AI isn't the same as autonomous or unmanned aircraft or unmanned flying. AI may be used in that, but they're not the same. Our fourth category is looking at airports and how they use AI tools. Many of them are starting to or want to start using them to monitor passenger flows to help better manage border control queues, which we as passengers I'm sure will all be happy with. And one of the other ways which is becoming a lot more newsworthy are biometric trials. Recognition, facial recognition, use AI tools. And that's linked to our last category of improving the passenger experience. This is on the airline side more, but airlines are using AI chatbots in their customer service functions, and they're also just trying to understand passenger behaviour better, so they can offer more personalised marketing, whether you like it or not. So that's where some of it's been used. And what's the uptake been? Some of these stats, or most of them, come from a CETA survey from 2019. And that found that 44% of airlines currently have a major AI program in use, and that's up quite a decent percentage from the year before. 89% of airlines are using or planning to use AI chatbots for customer service interactions. So that's the biggest use, probably because it's the easiest. It's not safety related or actually linked to the aircraft. I'd say all of these statistics are pre-COVID. It'd be interesting to see in a year's time whether the survey reveals different results. Airlines that use tech now may be the front runners coming out of the current crisis. We will see. Airports, 73% of them want to use predictive analytics. That's both on the passenger side and the aircraft side. And all of this is because of the increase in passenger traffic. IATA are expecting or predicting a twofold increase in the next couple of decades, largely from the Far East. But the number of people flying and the amount of data will again need analysis. So what then are the benefits and risks to the industry? Well, starting with the benefits, I think most of them are obvious, and we've talked about some of them already. Matt and Lee have touched on them. It's giving greater insight, helping the OEMs, MROs, airlines, airports, anybody in the supply chain to get greater insight and be more efficient and more reliable. Safety is probably not so well used at the moment, but Simon will talk about safety in a bit more detail shortly. So that's the benefits. What about some of the risks? Well, as again we heard Matt and Lee say, does AI pose new legal risks? And if you think about traditional human design software and how that works compared to AI, human design software looks at input data, it looks at experience, and it goes into a human designed algorithm. You know what comes in and and you have a good idea of what can come, what will come out, but you can analyze what's happened in the middle. With AI solutions, the problem is the black box that Lee mentioned earlier. This black box thinking is you don't know what's happening on the inside. You can't see how a decision is made, and so in aviation, that could cause some problems. If an output is wrong, you have to look at what is wrong, and if something is wrong in aviation, that could lead to casualties. But the question you have to ask is something wrong? Is anything actually wrong? Results that may seem wrong may just be unexpected. But if something has gone wrong, you can't necessarily find out why. Again, because of the black box problem, you don't know if anybody is to blame, but you have to look at the product and what could be to blame. Forgive me. It may be a problem with the data that's gone in, the data that's been trained. It could be that it was not enough data. It might have been used in the wrong way. It might have been biased data. There's all sorts of issues that would need to be looked at if you think a product is actually providing the wrong result. And all of this is true whether you're talking about an AI solution that's within a platform, within a piece of kit, or whether it's a piece of software being used on its own. I'll now hand back to Simon, as I say, to talk about some of the safety risks.
Okay, thanks, Lucy. As Lucy said, I think we had something of a debate as to where to put the safety piece on the use of AI. But just starting briefly with the way AI may fit into aviation regulation, I'm sure just about everybody on this call will be familiar with the structure of standards and recommended practices promulgated by ICAO, and how that structure is then implemented nationally by individual contracting states. So it's individual member states that will decide at the moment how AI is to be adopted in their aviation regulation, if at all, when we're looking at the safety aspects. In the EU, obviously, at the moment, it's the EASA, which takes that role still, at least for the rest of this year, including the UK. But the question that we were considering is how far we're going to see AI solutions analyses feeding directly into what I would call hard safety management, or how far, what the balance is going to be of that kind of benefit when compared with all the other commercial or efficiency-based solutions to which it's being applied. Obviously, across aviation, aerospace, and travel, as Lucy mentioned a moment ago, there's a huge range, and the safety piece and the hardware of the equipment and the operation of the equipment may only be a relatively small part of that. But to consider it by reference to an example, consider a piece of AI software which is designed to track a certain component on an aircraft and look at its reliability when it's removed, what its performance is like, and all of those sort of things. And it may come up with a clever way or a better way of positioning spares so that the parts are available at the points where they're most likely to be needed. Win-win result for the airline, because you may well be able to reduce inventory and transport costs and all that sort of thing, but you also get fewer AOGs because you've got a better insight into when you're going to need the parts. Compare that with the example of an AI module which looks at all that performance data and then says, well, actually, we can change the maintenance schedule. We can perhaps extend times on wing in certain circumstances, or perhaps the operating limitations around a part or something like that. First of those two examples is essentially an economic issue. If you get your spare parts positioning wrong, you've got disruption in the operation, aircraft AOG or something like that, but you haven't changed the criteria for release to service. And so, at least at a very straightforward level, safety is not in any way compromised. The latter example, by contrast, may go to safety critical elements, with the result that if you get it wrong, you might be regarded as hazarding the airplane in some way. And of course, the traditional mechanisms of safety management in civil aviation products is to build up the safety case for an airplane and all its components and systems by looking at all the failures, materials, parts, and so on. Identify the consequences and introduce mitigation or redundancy or whatever it is. And that depends on a very high level of understanding and predictability of the way the equipment is going to behave in service. And that, of course, becomes a whole lot harder if you have elements of the system where you don't know how they're going to behave, or you don't know how they're arriving at the decisions that they come to, or where perhaps behavior might change over time. And so there's issues about explainability and so on Lucy was talking about very much come into play. So quite possibly, and perhaps in the short term at least, there may well be a difference in the way AI becomes used in safety critical applications and those that are to do with commercial efficiency, the passenger experience, all of that sort of thing. So to go on, if I can have the next slide, please. To turn to, oops, sorry, yeah, that's the one. That's the background to EASA's AI roadmap. And this piece, I think, will feed very well into what Lee is going to say later on as to how Rolls-Royce have for real tackled some of the issues. But the EASA AI roadmap was first issued in February 2020. Interestingly, it's described as a dynamic document which is going to be reissued. That itself suggests a number of challenges, I guess, in the understanding of AI and how it's going to be used. Indeed, the document suggests a number, identifies a number of challenges that arise, issues of competency, industry support, coordination between the industry, the research community, the regulator, and how they're going to plan the work that's needed to get AI correct in the aerospace sector. It is a very generic document. From our point of view as regulatory lawyers, it really contains quite a limited regulatory analysis of how the structure around EASA and the regulations governing EASA are going to apply and contribute to this. What it does, picking up on some of the themes that in particular Lee was talking about, is it identifies the trustworthiness building blocks that are necessary. So there's the trustworthiness analysis, the learning assurance consent, the need for explainability, and the mitigation of safety risks. And it describes how those are going to fit together and how they, in turn, must be complying with the EU ethical standards, which are listed there. Apologies, you won't be able to read them on this screen. But I guess the summary is it's very much at the moment a plan for a plan. There's a lot of work. It has timescales going out to about 2035 for AI in full AI in commercial air transport. So there is quite a way to go, and the development of the rules around AI and the application of it by the safety regulator is obviously very much a work in progress. So turning briefly, if I may, to the aviation liability issues and how that might or might not change. Thinking first of all about product liability. We're often asked in the context of new technologies as well, do we need an entirely new legal system to govern all of this? And plainly across some areas of artificial intelligence, that's going to be necessary. But as far as the application of the adoption of AI within the aviation system is concerned, I don't see that significantly affecting the relationship between the industry on the one hand and the third parties. And essentially by that I mean the passengers and those who might suffer as a result of any of this going wrong, or perhaps third parties on the ground. As everybody knows, the law of product liability is well established. Manufacturers of products have strict liability. There's objective determination of a defect. One doesn't need to analyze issues of fault. If the equipment is not safe and injury or damage suffers, the manufacturer is responsible. Whether or not they use AI software, we don't see that, or within it, within the equipment, we don't see that position changing significantly. It may, of course, picking up on point I think was made earlier about the use or development of training data and so on, that may alter liabilities slightly, because you can see how it would be said that somebody or one producer in the supply chain may have altered the product. And there are, of course, the kind of issues as to whether a pure software supplier itself faces a formal products liability exposure. But that, I think, is something that's being addressed more in greater detail across all aspects of software. But if we can go on then briefly to carriers' liability, again, we do not see this changing significantly. The law, the basis of liability, the assessment of compensation, and all of that sort of thing in the event of aviation accidents are going to continue to be based on traditional principles that are very familiar to aviation lawyers, which I don't need to repeat here. That's true as far as our carriers' liability is concerned, their liability to their passengers, the way an operator or owner of an aircraft may be liable for surface damage. Those kind of issues aren't altered by the adoption by an airline or its suppliers of AI equipment within the operation or within the equipment. As we know, risks are almost invariably insured. Operators have realistic levels of cover available. And in the event of an accident, the operator resolves the immediate loss and looks to others for recourse if others are at fault. There are some areas which may be a little trickier, picking up on the points Lucy made about identification of fault and so on. So if you have air-to-air risk, that may be a little bit more complicated. Private operations, of course, where you don't have the same liability basis, may prove a little bit different from commercial, but that's a relatively small part of the whole equation. So within the supply chain, this is where I think things are going to change a little bit more, or where in particular lawyers and their clients are going to have to think in a little bit more detail about how the contracts govern their risk. If I can have the next slide, please, Lucy. So one would expect in the ordinary course that relevant parties are going to be linked by contractual arrangements. And of course, in the event of some sort of accident, the first thing that the first responder, the airline perhaps, does is to consider, well, what form of contractual recourse does it have? And so it's going to be looking to those contracts to see where it can identify a contractual breach of duty or some other fault on the part of somebody else, a supplier, maybe some third-party service provider or whatever. And the contracts need to look at those issues as well as looking at the other commercial risks that may arise from the equipment, for instance, in the event of inadequate performance or non-availability, or simply non-delivery of an expected result, or a saving in a commercial offering. They've got to look at a range of types of loss that might arise, which might be physical damage or injury or something like that, but they might well also be rework or rectification costs in the event of some sort of, in the absence of some sort of safety defect or accident occurring. But in any event, whether we're talking about the casualty situation or commercial losses, any third party who has suffered loss or any contractual counterparty is almost certainly going to look to the person with the most money, as has always been the way. And so with that in mind, I'm going to pass back to Lucy to talk about the risk management issues.
Thanks, Simon. Yes, just to finish from me and Simon before I hand to Lee, I think some of this new technology or not so new technology does require a bit of new thinking, but a lot of the risk management tools that businesses have used for decades still apply. They perhaps just need to be adapted a little bit. Risk assessments, for example, will all still need to be done, but perhaps now, rather than commercial, legal and technical risk assessments being done perhaps in silos, they now need to be done together, because the issues that come from one area very much feed into another. So they all still need to be done, but teams perhaps need to be more joined up than before. Testing, I mean, it goes without saying that all products will be tested. Again, now though, does testing need to be done in a different way? Do you need to do more of it? Do it in a different way? Keep testing until you don't get unexpected results, as you may do with AI before something goes live. It's a very important area, and lawyers won't be able to tell technical people how to test, but the output of those tests is something that should be documented, which I'll come on to in a moment. The third area is insurance, which is obviously very important in aviation, and insurance doesn't necessarily need to change, but it needs to be looked at to see whether any extra cover is needed. Do you need AI specific insurance? It may be that you don't. A problem caused by an AI system on a product may be covered by, for example, your business interruption insurance. So you don't need anything specific, but you do need to consider the cover that your current insurance offers you, and whether problems caused by an AI system are covered. And then lastly, this is what Simon just talked about. Your contracts and your supply chain, the risk allocation in that supply chain are probably more important now than before. Airlines will continue to be at the sharp end because of their strict liability regime. But the question of who is providing data, who is training the data, who is testing the system, will be different to a traditional software model. So, for example, a fitness for purpose warranty that may traditionally be given by a software developer, they are unlikely to want to give such a warranty now because they don't know that the results that the AI tool gives will be fit for purpose. So there will need to be some careful thinking in your contracts, depending on where you are in that supply chain, to make sure that the risk is allocated appropriately, but that it is documented, because it's the only place that you will be able to properly pass risk if that is your intention. That's all from Simon and I. I will now pass back to Lee, who will talk us through a bit more of the flesh on the bones on how Rolls-Royce have been using AI.
Thank you, Lucy and Simon. So I'm going to take you on a journey through the development of AI in Rolls-Royce, very much based around engine health monitoring and predictive maintenance. I'll touch on other areas as well as I go through. So just looking at data science history in Rolls-Royce. So in 1980, we started taking data from test beds and look at what could we learn about the engines from doing data analytics on that data coming off the test beds. In 1998, we started taking it at end of flight off real engines from real aircraft. This enabled us then in 1999 to set up a disruptive business model where total care came in and eventually corporate care, which was where there was basically an exchange of risk. Rolls-Royce would take the risk for maintenance and overhauls, and the airlines would pay $1 per flying hour effectively. So a completely new business model came in at that time. 2005, we started taking data actually off the aircraft in flight, so VHF ground network or satellite comms, and the development there of real advanced analytics using diagnostic networks, machine learning, AI. And at this point, we would have been able to use the term the Internet of Things, but that didn't exist in 2005. But it was artificial intelligence and satellite communication of the data from flight. 2010, end of flight, Wi-Fi connectivity for very high frequency data. 2015, AI 2.0, which I'll come to in a moment. So this is where we are now. Looking on the right-hand side, over 11,500 engines are hooked up to the predictive maintenance engine health monitoring. Roundabout, under normal circumstances, 7,000 flights a day, and we're monitoring those flights 24/7, 365. So while you're on an aircraft Christmas Day having lunch, we've got people in Derby ensuring that these systems are working and continuing to work. On average, at any one time, there are 3,000 engines in the sky, all being monitored, and it takes us about 3 minutes to take the data, acquire it, transmit it, and then analyze it and provide an insight to an engineer if there is one. And this is what it achieves. So it was a record last year, but 50,000 flying hours without overhaul on an A330 owned by Aeroflot using our Trent 700 engines. What that means is, effectively, the engine was switched on, not switched off 5 years. That's the equivalent of. So take off land continuously for 5 years. For the same distance, the average car would undergo 2,000 services, the same amount of miles. We kept the engine on wing for that amount of time with no overhaul. Closer look at the engine. So going down the centre line from the left, the air comes through the fan, goes through 8 stages of intermediate compressor, 7 stages of high pressure compressor. At this point, the air is at 50 atmospheres pressure. It then goes through the combustor, fuel is injected, the mix is ignited, then the gas that comes out the back of the combustor goes to the high pressure turbine. The gas temperature is higher than the melting point of the blades. You can see my camera, I'm holding up one of those blades. So that blade is sitting in a gas temperature higher than its own melting point. Each blade produces the power of a Formula One engine. Each blade costs over $5,000 when it's finished and goes into the engine. Incredible piece of technology. Why am I telling you all of that? Because this is the environment that we're going to take the data from sensors, take it down to ground and analyze it. So going back to that timeline, 2005, those diagnostic networks, if I look at the latest Trent 1000, there are 155 when the engine goes into service. Some of them are very simple, looking for limits. Some of them extremely complex, using machine learning, artificial intelligence. And then from 2015, we've been bringing on board AI 2.0, which is now on all of our engines. Those 11,500 engines also have got AI 2.0 looking on them as well. What is AI 2.0? Effectively 26-dimensional multivariate analysis, operating on all of the engines in the sky at any one time, 24/7, 365. So complicated, we cannot program it. It programs itself. It learns what normal behavior is. It doesn't need us to pre-configure any fault signatures. It teaches itself what to look for and then looks for the anomalies. It's searching for the anomalies. The engineers don't need to search for the anomalies anymore. They just concentrate on analyzing those anomalies when the AI system identifies them to the engineers. So self-learning, looking for anomalies. We're looking at migrating all of these technologies across our businesses, so be it into MTU engines, which is a Rolls-Royce company, onto Great Western Railway trains, or onto the Royal Navy's aircraft carriers, which use our gas turbines for propulsion and generation, or into our manufacturing, same thing. It's all data, it's analysed by artificial intelligence. Moving into business processes, contract admin, repetitive business processes, document sifting, including CVs, which we've referred to earlier. And all of them then have got the same trustworthiness potential issues where AI is involved of mutation and bias, producing untrustworthy outputs. So the same model I presented in the very first stage. So if we're looking specifically at predictive maintenance, then the untrustworthy output very likely will lead to maintenance too early or too late, neither of which are optimal. If you leave maintenance too late, you'll probably end up doing too much. If you maintain too early, you'll do too much. And our own whole disruptive business case is built on doing maintenance at the right time. So what do we do? Taking those Rolls-Royce 5 checks philosophy, the generic that I presented earlier, we then go into specifics on how will we apply that to where we're looking at predictive maintenance. So the same sense check, first one. So within our predictive maintenance system, we've got 14 sense checks, looking at things like, has the engine got younger or older every time it's flown Have we got the right parts being analysed? Various things like that. There are 14 sensor checks. The continuous test system consists of 1 million synthesized flights, which effectively is an airline, which is pumped through the system 200 flights a day, which is the equivalent of an MOT on the system every 15 minutes. An independent check, which is a completely independent set of data taken from the engines, taken through independent algorithms, which gives you a completely independent check on the system as well, checked to 10 decimal places, so we're pretty sure that the right answers are the right answers. Comprehensiveness check looks at the flight records of the aircraft to check that we've done the right number of calculations, and there's a cyclic redundancy check on all of the data through transmission to ensure that there have been no corruptions of the data. That's how we ensure that the predictive maintenance system is giving us trustworthy answers. We're continuing to research into AI bias and mutation. So the hypothesis was, is there any biomedical science techniques looking at genetic mutations that we could use within AI mutation within industry? So looking at a short form, a genetic mutation is a change in coding portions of DNA, which may alter the sequence of proteins, which has the potential for changing the expression of the gene. An AI mutation is a change in coding in portions of the AI application, which may alter the logical instructions, which has the potential for changing the expression of the AI. So the hypothesis is very, very strong. So I produced a research paper. We've had it peer reviewed by a consultant neurologist from Queen's Square Hospital, looking at the techniques. Are they transferable? And absolutely peer review that there are techniques within genetic mutation that we're looking at transferring into looking at AI mutation. And interestingly, within genetic mutation, they've got something that's very, very close to those 5 checks that we're already doing. But beyond that, there are things that we can look at, which are more inside the black box, looking at fit, form, and function type applications. That's the end of my talk. So handing back over to Gilly for any more questions.
Lee, thank you very much indeed. I hope everyone can hear me. But thank you very much indeed for that walkthrough of how Rolls-Royce has tackled these issues. And thank you also to Simon and Lucy for a very interesting talk on how this might impact the aviation sector. I've got a number of questions here, which I think some of which we will have a chance to get through. Perhaps one to kick off with is it possible that members of the panel can give some examples of ongoing research in AI and ethics in UK universities that you know of? Now, obviously, we've just heard from you, Lee, in relation to a paper you did that was then peer-reviewed by a university, but are there others that you're aware of that people can maybe get access to?
I can certainly answer that. We are working with universities. There's a lot of it is happening. We normally try and work with universities and industrial research as well. So the AMRC is a great place where you can bring together the academic side, especially Sheffield University being right next door to the AMRC. But the big industrials are in there as well. So the Microsofts, the Googles, Rolls-Royce, Boeing, Airbus, all together in the AMRC. So doing some incredible research into the AI area as well.
Okay, thank you very much. Maybe this one is for Simon and for Lucy. We have a participant who's asked how far AI can go into aerospace technological applications that may affect human freedom and established human or state sovereignty rights. Would you like me to repeat the question?
Yes, please.
Maybe certainly the last bit. Yeah.
Yes.
Yes, the participant has asked, how far can AI go into aerospace technological applications that may affect human freedoms and/or established human or state sovereignty rights? So the right that a state would have over its own sovereignty, how might that be affected by AI being put into technological applications? And I guess the same question in relation to human freedoms and human rights. I'm thinking possibly human rights, freedom of speech and so on. We've talked a lot about the privacy of data. We haven't talked about perhaps freedom of speech.
I think, and Simon may disagree on this, but I don't think AI would impact any sovereignty rights that exist at the moment. They're pretty fundamental, and I can't see how AI's use across the sector would change what's in the Chicago Convention at that very basic level. I think AI applications will continue to evolve, and as we've all said, at the moment they are looking at efficiency and reliability. There's a long way to go for safety applications, I think, and EASA are looking at it now. I think it is, even though AI has been around for a long time, it still feels, and Lee may disagree, but in some ways in its infancy in aviation compared to other sectors like fintech, media. It's perhaps easier to implement in those sectors. Aviation has a huge safety culture, and I think that will be the driver for its popularity in the next certainly few years and decades to come.
Thank you.
Yes, I mean, I think from my point of view, there's certainly a long way to go in terms of the potential. But you can certainly see when you look at things, you know, the human rightsy kind of aspect. If you're looking at, you know, biosecurity and things like, you know, maybe pertinent at the moment, you know, how, you know, in a future world, airports are going to manage significant volumes of people who may need some form of health screening or something of that nature, and that sort of data is then, you know, being used, or there is a demand to use it on a very wide scale, because perhaps we're looking at health security on a global basis. There will be huge differences of view across the world as to how that data can and should be used, and what the, you know, the personal privacy type issues are. I confess, I generally look at this from the aviation safety end of the spectrum and the commercial relationships within the industry, and I'm very glad to have, for instance, a very good team of data protection and privacy lawyers who are all over this. But I'm afraid that particular one is not quite my area.
Yeah, thank you. It's an interesting question. Thank you very much indeed. I've got a question here about AI and integrated cabin technologies. I think there's a lot of chat on the internet about the quality of cabin air. We've heard Boeing say that the air in their newer aircraft is at operating theatre standards, so none of us need worry. I think most people take the view when you travel, particularly long haul, you're subject to recirculated air, which may not be the air that they'd want to be breathing for 6, 8, 10, 12 hours. So is there any sense in which AI can help with cabin technologies, antiviral technologies in confined spaces, that kind of thing? Or is that a subject that we're not yet seeing developments on?
I think I haven't seen anything quite that specific, not to say it's not out there. I think in the cabin it's more about passenger behaviour and sort of in-flight connectivity. I think as part of aircraft design, and again, Lee, you may know more than me, or Simon may know more. There is inevitably, they're looking at every angle, but for me, I think it's more about, you know, the passenger sitting on a seat. How can airlines sell more to that person? How can they understand that behaviour more, and what does that look like?
So answering the question, there obviously have been occasions where passenger have complained about cabin odour. I don't see it as an AI issue. It's more of probably around how the aircraft has been maintained, how it's been overhauled, etc. Not really anything I see AI. I mean, AI can be used to analyse the data to find out what the root cause is, which is one of the things that we do a lot of. If we start to see some sort of trend in that sort of a thing, we'll use AI to do a lot of data analytics, because AI is fundamentally faster at analysing lots of data than humans generally are.
Yeah, thank you.
I would assume that because AI is dependent on a lot of data coming in order to analyze it, it would depend on the kind of monitoring that you could have within the cabin on the cabin air issue, and I just don't know what's in the bounds of the possible in that context. But it feels to me a bit different from the hundreds of parameters that they're measuring on the engine at the moment, but which has taken many years to evolve.
Yes, I think it shows where people's concerns are at the moment, but I think experience is like yours as to where one's currently sort of seeing it. Simon, I've got a question for you. We all know that EASA is its primary function is safety. Do you really think it should be concerned with ethics?
I suspect Matt might actually have a view on this as well. I don't know if we can get him in on it. I mean, the simple answer is, of course, yes. Every institution and every regulator should. And I confess I was left a little bit confused as to quite what the relationship between the safety role and the ethical guidelines were. I think any regulator should be concerned that it's not doing anything inconsistent with the ethical guidelines. But does that mean that EASA should be formulating its own policy on the societal good generally? I think the way I would look at it and the way I would see a safety regulator's function is our primary job is to make sure that these airplanes are not falling on the wrong people in the wrong place and things of that nature. That's a relatively sort of simple approach. I mean, we've seen in a number of instances over EASA's life of the regulatory process engaging other issues. Typically societal, sometimes privacy type related data gathering issues, and you think, well, actually, that's not really I don't think that's really an aviation safety issue. If we've got a privacy law over there, let them deal with that, and don't make EASA have to work out all the soft ethical issues. That's not to denigrate them in any way. Matt, you're fascinated with the interaction generally of ethics and law. You may have more to say on that.
Yeah, well, I think I agree with your analysis, and I think EASA's, and you had it in one of the slides earlier, their flow chart going from the overarching EU guidelines for ethical AI, and they're processing it into sort of technical outcomes. And I think they can't float back up the chart to change the overall ethical guidelines. What has fascinated me is that we are in such a fast-moving area of technology that the law simply can't keep up, and so it is, I think, unprecedentedly important that companies think at an ethical level. And I won't name the company, but one of the key AI companies, I was talking to one of their in-house lawyers, and he said that increasingly one of his roles is simply to tell people internally to speak to the ethicists first, as it were, the first line of defense, to make sure what they're doing is right and proper. And only if they're creeping outside the ethics would they check if it's also within the law, but they expect the ethics circle to be tighter than the law.
And I suppose you could add to that When I think of one of the other areas I get involved in, which is the whole compliance world, particularly around issues like bribery and corruption. 15 years ago, people were asking within many organizations, well, what's legal or illegal? Now, the ethics world is much more front and center, and it's front and center, in the boardroom and in the position, the whole ESG piece that any business must be concerned with now, because if it isn't, it doesn't just fall foul of the prosecutor, but it falls foul of the court of public opinion. So that I agree with you entirely. That ethical piece is absolutely vital. Quite how it relates to aviation safety is a slightly different point. So it's front and center.
And very difficult, of course, to decide what the court of public opinion would decide on matters of ethics from time to time. Agree with you, Simon. That's obviously, as you say, front and center. I'm going to come back to a sort of engine tech question, and then we're going to come back to the panel for one last question, I think, before we wrap up. And this is one for you, Lee, I think. The participant has asked, are you exposed for a time as the system learns a new engine or variant of an engine or a new sensor? Or how do you sort of factor that in when applying AI to your engine data? Or does all that happen before?
I mentioned that since early on, we've been putting in diagnostic networks. I mentioned the 155. So when the Trem 1000 took to the skies, it had 155 diagnostic networks that were pre-configured from working with the engineers. What insights would they need using their massive simulations? So digital twin type technologies that identify what they know they want to know. The AI 2.0 that's self-learning is protected effectively by those 155 algorithms that have been put in there from day one that are all pre-configured. Still using machine learning, etc., but the protection's already in there. The other thing, so the self-learning that goes on then to look for unexpected is protected by the 155. What I would say is that nowhere within the engine is this going into safety critical. The engine is safe to fly, even if we switch all of these systems off. These systems are there to maximize the availability for the airlines, minimize time off wing, minimize maintenance whilst the engine's on wing. So we'll be able to spot if you need to change a fuel filter, for example. That signal will be established whilst the aircraft is in flight. There'll be a maintenance crew there on the ground ready to change a fuel filter. Passengers won't know. The aircraft will not be delayed. Those are the sorts of things that the predictive maintenance is in there for, is for maximizing the availability, not for trying to manage safety.
Lee, thanks so much for that. Right, I'd like to finish with one sort of wrap-up question for the whole panel, if I may. We perhaps touched on this a little bit in the penultimate question, but the question is, what is the panel's thoughts on the type of leadership required to see AI strategies successfully through at a company and at a national level? We've touched a little bit on the court of public opinion, always a fickle thing, I think. We've touched very much on the ethical aspects. I think, Matt, your comments on that were fascinating, that how run it past the ethicists first and then the lawyers. I thought that was really interesting. But what would be your advice to somebody in a thought leadership role to guide a company? What would be our advice to Boris to guide the UK through this at national level? Who would like to go first? Shall I pick on somebody? Lee, I'm going to look at Lee first.
I think there's so much bad press around at the moment talking of the AI winter. AI can't do X, Y, and Z. Well, try putting a screw in with a hammer. You'll put it in wrong. AI is very, very good at certain things. People then compare it with a human the latest is around dexterity and locomotion and those sorts of things. So a human could could put a screw into a hole with its fingers far better than an AI robot could. Well, yes, so what is what I say. You know, choose the right things for the AI, and it will outperform humans. It will provide massive benefits using it for the right things. It is a tool. It has got limitations. It generally won't beat a human on the subconscious. It will generally beat a human on the conscious. So things like Go and analysing lots and lots of data, it's fantastic at. So using it in the right place for the right things, it will get better, but don't be critical of it because it can't do certain things. Very few tools can do everything. But what it's good at, it's very, very good at. And for me, that is one of the things that we need to understand. It needs to be part of a system. Don't rely on it to do everything itself.
Thank you, Lee. Lucy.
Yeah, I mean, I'd agree with that. I won't advise Boris. I'll leave that to others. But I think the leadership has to want to do it. They have to see the benefits, and they have to have the not necessarily a person with the knowledge, but with the foresight that AI can help. And like Lee says, use it as a tool in a box of tools that can lead to a better result overall. I think that we have clients who don't yet see the benefit that data can bring, so they're not yet going to see the benefits that AI can bring. I think the leadership team has to want to do it and then use it as a way to achieve an end result and know what that end result is, rather than using the AI to be the end result.
Yes, I'd agree with that. Simon.
Yes, and one of the questions that was going through my mind listening to what Lee was saying earlier, I think back to his presentation, his 5 methods of checks and balances is, well, so you look at it, and one of your perhaps warning flags is when it comes up with an unexpected result, and you're thinking, well, actually, isn't the whole point that you want to get a slightly unexpected result? And so I suppose my suggestion would be that where the AI is coming up with unexpected results or recommendations or whatever it is, the leadership has to make sure that they are listened to. Those results are observed and not simply disregarded because they're unexpected. It's a bit like, as we're always told, the one person in the room who thinks slightly differently and who raises an objection at the end of the meeting. Well, actually, you shouldn't be disregarding that because it's a surefire way, among other things, to lose your team cohesion and that sort of thing. So I would suggest as a piece of however unexpected the result, make sure you are, or the outcome, make sure you are looking carefully at that with your appropriate checks and balances to verify why that is. And learn from it, whatever.
May I respond to Simon?
Yes.
The checks and balances aren't looking at what the AI answer is per se. They're looking at what some standard inputs and standard outputs would result in. So it's actually looking for a malfunction within the system by using synthesized data, for example. So the synthesized data will identify if the system itself has mutated. So it's not specifically looking at the daily inputs and outputs. It's looking at putting synthesized inputs, looking for an output to see whether the system is malfunctioned. So if the AI throws up a very unexpected answer, the checks and balances won't be looking at that. The checks and balances are looking at whether the system that produced that is malfunctioning.
Okay.
Yes.
So thanks for asking the question, because that's helped me clarify how it works.
Matt, would you like to wrap up on this question?
Yeah, sure. So if we're talking at the Boris level, the sort of governmental level, I think we are actually in very safe hands, because I think we already have the Centre for Data Ethics and Innovation, which is doing fantastic work. I think our industrial strategy put the Turing Institute dead center, and that's 5 institutions in one looking at how AI should work. And you only have to look at their collaboration with the Information Commissioner to see the quality of work that comes out of that. And really, I think I would echo what everyone has said, is that an awareness, a technical awareness of the limitations is really vital. And you only have to think about people following sat navs off cliffs to realize that this needs to be reinforced, and that people will throw away privacy rights in return for free email and the like. And so I think some level of oversight is needed. And really, in order to capture that potential, what you need is a rolling program of regulatory change. And that is exactly the model the UK has taken when it comes to the testing of autonomous vehicles. It's a rolling program. So hopefully we'll avoid that 13-year delay. And slightly more controversially, I do wonder if we need an equivalent of the sort of safeguards given to early internet companies to shield them from liability. And whether, in order to get autonomous robots, autonomous flights, autonomous cars on the road, we actually need to give private companies some comfort that they won't be hammered utterly through the courts and through damages when things go wrong.
Matt, that's a very interesting answer. I think there were excellent answers from all 4 panelists. Thank you very much indeed. And thank you to all those who sent fascinating questions in. I'm sorry we haven't been able to cover all of them. But Michael, I'm going to hand back to you, I think.
Julie, thank you very much. And thank you to all of our speakers. That was a really fascinating hour and 3/4 when we covered a hell of a lot of ground, but all extremely interesting stuff. From my perspective, just a few wrap-up comments. It was really nice to discuss a topic which is extremely forward-looking and all in a sense about future-proofing the industry, because I think it's a nice reminder to us all at this particular point in our history that we have a future, that our industry has a bright future ahead of it, that the topic of AI, but a whole range of other regulatory topics are going to become very crucial in that future. And so I think the whole tone of the seminar looking forward, I find particularly reassuring and encouraging at the moment. Just a few highlights. Great to hear from Matt. As always, as lawyers, we like definition, and Matt gave a really good intro to define the scope of the topic. He noted the perhaps a warning of this race to regulate, and there was a bit of discussion about EASA's role in regulating in this whole area, and we've seen a lot of mission creep with EASA in recent years, not just here, but in a whole range of topics, not least of which environmental protection, a topic close to my heart. And I think we as industry, certainly as an industry body, but many practitioners will be interested to see how EASA continues on that road. But Matt also talked through this crossover between law and ethics, which of course is so crucial here. Hearing from Lucy about the whole range of potential applications in aviation for AI and the benefits that it can bring, I thought was absolutely fascinating. And then Simon showed us that with those benefits, of course, come legal risk, and that's not just in our traditional aviation liability areas as we know them, but also in looking into a whole broader range of topics. And then Lucy, of course, ran us through where risk management and risk allocation plays into that. It was brilliant to hear from Lee, not just a non-lawyer in this group, but also to hear from a real industry insider, and certainly from a trade body perspective at IATA, but I guess also for many practitioners, we often look at these issues in abstract. We need, I think, a reminder that these are day-to-day realities for the companies and the organizations that we serve. And so terrific to hear how Rolls-Royce has taken that journey forward and turned, as Lee said, turning data into insight. those, without revisiting the whole scope of the webinar, were really some of the thoughts I'd retained, and of course all extremely ably moderated by Gilly, who directed the questions and the discussions, and I think got really a lot of insight from this panel of experts that we can all use going forward. Let me close by just saying again, we are in the eye of this COVID-19 storm. The things look quite bleak for the industry in the short term, but I do think it's incumbent on all of us to continue our focus on these long-term strategic issues like AI. We're clearly on the beginning of a journey here, but it's one which the AirLaw Group, working through the society, will continue to keep an eye on it and play whatever role we can. And I think this is clearly a topic where we want to get together in the future and have more in-depth discussion. I really feel we scratched a little bit beyond the surface, but probably didn't go as far into the topics as we easily could have done. So let me close just by saying, on behalf of all of the members of the AirLaw Group, thank you to our speakers. I know you spent a lot of time in the preparations for this, but it just from my perspective was certainly time well spent, and it really was a terrific insight into a fascinating area. Thank you to all of our participants. Again, huge interest in this, and we look forward to seeing you all in person. And from the AirLaw Group, best wishes to everybody in the current times, but also we'll hope to look forward to happier times to come. Thank you very much. Enjoy the rest of the afternoon, and look forward to seeing you all again very soon.
Thank you.